Hi, everyone. Here we go. The frame method for graphing trig functions. I think some of you could really like this as a superior alternative to what you did in Math 104. But if you like your old school way of doing it from your trig class, that's fine. Just make sure you give me all the information that this method would give me on a standard problem. All right. Now, the mnemonic or memory device is PCAPI. Actually, I'm going to add an A at the end, PCAPIA. I kind of made this up, but it's easy to remember. PCAPIA. Frame method is basically PCAPIA. To graph y equals a sine or cosine of bx, and will extend to other trig functions later on. PCAPIA. PCAPIA. First P for pivot. The left center point on the frame is the origin for now. Later on, it might be translated elsewhere. C for cycle shape. That's from this grid over here, remember? First A for amplitude is the absolute value of A, half the height of the graph. Second P for period, 2 pi over B. Remember, if B is negative, use the even odd identities to make sure the new B is positive. I for increment, which is always 1/4 of the period. This will help us graph. It's the step between our key points on our graph. And finally, A, PCAPIA, A. Last A, we will superimpose the coordinate axes, perhaps not to scale. Okay, so put in the coordinate axes and label them. We usually do this first. But you know what? Especially when we translate, we might want to do it last. PCAPIA. Don't forget the axes and to label them. Let's apply this idea. Example, use the frame method, or not, you can use your method, but give me all the information we'll see here. Use the frame method to graph one cycle of the graph of y equals -3 cosine of -4x. There are infinitely many possible cycles or answers, but the frame method will suggest a particular cycle. Okay, big problem. B is what? B is -4, which is negative, and we don't like that. So we're going to use the fact that cosine is what? Even or odd? Cosine is even. So what can we do with the negative sign here? This -1 is a factor on the argument. We can kill it. Because cosine is even, so that means that the negative sign here, we can delete. This is equivalent. Y equals -3 cosine of 4x. I'd rather graph that. We're going to get the same graph. Right. It helps that -1 is a factor here. If you had a loose term in there, like a plus pi or something, then you'd have to factor out the -1 first. All right. The pivot is at the origin, 0, 0. We're not translating yet. Cycle shape. Okay, B is positive. I'm assuming B is positive, by the way, when we do this. We have cosine, and A is negative. You should have the cycle grid in mind. Cosine, if A is positive, we have the valley, but if A is negative, we flip over to this hill or pimple. We want this over here, the hill, if we're going to apply the frame method. Amplitude, the absolute value of A, the absolute value of -3 is +3. The period is 2 pi over B. What's B? Okay, well, let's look at the new value of B. The new value of B is 4. The new value of B is 4. Positive. 2 pi over 4 simplifies to pi over 2. The increment is always 1/4 of the period. 1/4 times pi over 2, multiply across, is pi over 8. It's going to be the distance between each of these vertical grid lines. And then don't forget to put in and label the axes at the end. All right. We have enough information to do our full-blown example. All right, we're going to do the full-blown graph. And actually, I'm going to go ahead and duplicate my file here. All right. And we're going to see what we get. All right, here we go. The answer is here. Let's explain why. Okay, PCAPIA. How does it give us the answer? The pivot. Left center, 0, 0. Notice 0 here, 0 over here. Cycle shape, we have the hill. And we're going to get 5 key points, remember. 5 key points. This min point, this inflection point, this max point, this inflection point, this min point. Amplitude is 3. 0 plus 3 is 3. 0 minus 3 is negative 3. By the way, the range will be from negative 3 to 3. Period? Pi over 2? Well, if this is 0, the period is over here, pi over 2. It's the width of the frame. Increment, pi over 8. That's the number we're going to keep adding. 0 plus pi over 8 is pi over 8. Pi over 8 plus pi over 8 is 2 pi over 8. That simplifies to pi over 4. 2 pi over 8 plus pi over 8 is 3 pi over 8. 3 pi over 8 plus pi over 8 is 4 pi over 8. That's a check. That simplifies to pi over 2, the period. By the way, if this is 0, then this here is the period. Bear in mind, if this is not 0, then this will not be the period. But since we're not translating yet, the period is here, pi over 2. Finally, the axes. The equation of the x-axis is y equals 0. Well, here's 0. Label it x on the right end, the positive end, not the left. The y-axis is at x equals 0. Here's 0. Is at the left edge. Put the y here on top, not the bottom. We put the labels on the positive directions. And there we go. That's a completely labeled cycle for the graph. All right. What about translations? By the way, if you need a second cycle, you can go on the other side of the y-axis and subtract or use symmetry. Translations. This should sound familiar. All right. So what if we wanted to do a translation so that the origin 0, 0 becomes the point, not HK, PD. This is standard notation for trig, P comma D, where P is the horizontal or phase shift. I'll type that out. P is the horizontal or phase shift. And D is, as usual, the vertical shift. Well, it's usual for trig. Okay. Remember what we do. If we do a horizontal translation, we substitute x with x minus p. We substitute the x here, or here with x minus p. Substitute with x minus p to do a horizontal shift by p units. To do a vertical shift of d units, just attach a plus d. So it's easy to read off a vertical shift. So these are our general transformed sine and cosine equations. And they lead to transformed graphs. Okay. So how do we use the frame method in the case of translations? Fortunately, it turns out this is just a translation of the guy we just did in the previous example. Use the frame method, or use your method, to graph one cycle of y equals negative 3 cosine of 4x plus pi, all plus 2. Again, much of PCAPIA will be the same, but there will be some differences. All right. So for example, how do we find the phase shift? One method is to factor b out of the argument. Right now, the argument is 4x plus pi. B is 4. Factor out the 4. You get x plus, when you factor, you divide. We get pi over 4 here. Okay. And what is x plus pi over 4? It's x minus negative pi over 4. So p is the phase shift. Remember, in this general format, p is the phase shift. So over here, p is negative pi over 4. It's what makes this equal to 0. What is the value that makes this equal to 0? Negative pi over 4. All right. So the phase shift is negative pi over 4. D, we just pick up here, the plus 2. So the pivot, P comma D, is at negative 4 comma 2. That's where the origin is moved to. It's at the left center of our frame. Now, if you thought the factoring method was a bit too confusing, as long as B is positive, if B is negative, you really need to factor something, at least a negative 1 out. But if B is positive, well, there's an easier way to do things. You just go ahead and set this argument, 4x plus pi, equal to 0, and solve for x. 4x plus pi equals 0. To solve for x, you subtract pi, divide by 4. X is, hey, negative pi over 4. That's the same phase shift that we got before. Okay. So that is the key difference. Everything else is the same. Cycle shape is a hill. Amplitude is 3. Period is pi over 2. Increment is pi over 8. Remember, this guy was a transformed version of our previous example and put in the axes. So the pivot, that's the new thing here. And what is our new answer, our new graph? The coordinates and axes will be the things that really change. All right, the same picture, it's a hill. What's different? The pivot is at the left center of the graph. The pivot is at negative 4, comma 2. The left center of the graph, where the origin is moved to, is at the left center. It actually is not a point on this graph, this cosine graph. All right, cycle shape, it's a hill. We can draw on this hill with the 5 key points here. Amplitude is 3. We have to do some arithmetic. 2 plus 3 is 5. That's the y-coordinate of this max point. 2 minus 3 is negative 1. That's the y-coordinate of these min points. You must write down these numbers. The period is pi over 2, but this here is not pi over 2 because the left number here is not 0. So in a way, we do not use the period directly. We use the increment directly. Okay, the increment is pi over 8. Ooh, well, this is in fourths, so let's convert to eighths. Negative 1/4 pi is negative 2/8 pi. 1/4 is 2/8, right? So negative 1/4 pi is negative 2/8 pi. Negative 2 pi over 8 plus 1 pi over 8 is negative 1 pi over 8. That's simplified. Negative 1 pi over 8 plus pi over 8 is 0. Wonderful. We can keep adding pi over 8, or we could just use symmetry. Pi over 8, symmetry about 0. This is pi over 8. This is pi over 4. Where does the period come in? The period is pi over 2. Where does the period come in? Pi over 4 minus negative pi over 4 is pi over 2, the period. The period is the width of this cycle. Pi over 4 minus negative pi over 4. That's the period. All right. A for axes, remember, that was the missing piece here. PCAPIA, you got to put in the coordinate axes. Got to put in the coordinate axes. All right. The x-axis is at y equals 0. Okay, now 0 is between -1 and 2. I'm not going to get out a ruler, but make sure that the x-axis is between this line over here and this line over here. 0 is between -1 and 2. Okay, and then label the x on the right end. The y-axis has equation x equals 0. It's right here. Put the y up on top. Sorry about that. Put the y up on top. All right. That's a cycle for a transformed trig function. All right. So after today, we're going to look at the other 4 trig functions. Until then.